Assalamualaikum dear all, I hope you all are good. Today we'll be starting with the enzyme kinetics. It's not in your syllabus, but moving forward to the enzyme inhibition, you must be aware of the enzyme kinetics. So I'll be just giving some details about the enzyme kinetics. So moving forward, let me tell you what happens. Say for example, if enzyme and substrate combine, they form enzyme substrate complex. Fine, they form enzyme substrate complex, and this reaction is reversible. This enzyme substrate complex can break and change back into enzyme plus substrate. Fine. So let me tell you, for instance, if we take the rate constant of this reaction, enzyme plus substrate changing into enzyme substrate complex, if we take the rate constant of this forward reaction as K1, let's assume the rate constant of this reaction is K1, and let's assume the rate constant of this backward reaction, which is reversible also. I told you enzyme substrate complex breaks down into enzyme plus substrate. Let us take it K minus 1. Fine. So here the rate constant of this forward reaction is K1 and this backward reaction is K minus 1. Fine. So moving forward, you already know that the enzyme substrate complex further, it changes into substrates get changed into products. So enzyme remains as such in the reactions. Enzyme don't get used up. It remains as such, and as a result, what is formed? Enzyme plus product. So let's assume the rate constant of this reaction is K2. Fine. So here we have three rate constants: K1, K minus 1 and K2. Fine. So let me tell you, I already told you, I have written these here. K1 is the rate constant for the formation of enzyme substrate complex, this, and K minus 1 is the rate constant of this backward reaction, which is a reversible reaction, and K2 is the rate constant of this reaction. Fine. So moving forward, let me tell you, according to Michaelis and Menten approach, these were two separate scientists. One was Michaelis and another was Menten. What he said, according to this approach, when the rate, also called the velocity, rate of a reaction is also called the velocity of the reaction, is measured at varying substrate concentration, the rate depends upon the substrate concentration. He said that the rate of the reaction depends upon what? Depends upon the substrate concentration. Rate of this reaction depends upon this substrate concentration, like how much substrate is added into the reaction. Fine. Rate depends upon this substrate concentration. So moving forward, let me show you. If we plot a graph against the substrate concentration and velocity of the reaction, which is also called as rate of the reaction. Here we are plotting a graph against the substrate concentration and the reaction velocity, which is also called the rate of the reaction. We get a hyperbolic graph. So what does this hyperbolic graph denote? Like if we have the initial velocity V, we have a initial velocity of a reaction, that is V, or initial rate of the reaction, that is V. Upon adding the substrate, it keeps on increasing, and then it reaches a maximum value, that is the V max, where it attains the maximum velocity or maximum rate. After that, it starts leveling off, or it becomes steady. So such type of graph is called as hyperbolic graph. It's called as hyper. Here we get a hyperbolic graph. So let me tell you what happens. Here it's V max. Fine. Here it's V max, the maximum velocity of a reaction, after which it starts leveling off. And half of this, if we take its velocity half the way, that is V max divided by 2. That means half the maximum velocity, that is V max divided by 2. Now let me tell you, here I have to another parameter here, that is Km. So what is this Km? It's a Michaelis-Menten constant. the substrate, it is actually that substrate concentration. यहाँ पे देखिए आप इस एक्सिस पे मैंने substrate concentration plot की है. So it is that substrate concentration where the velocity reaches half of its maximum velocity. It is that Km is that substrate concentration. ये substrate की वो concentration है where the velocity reaches half the maximum velocity, half the maximum velocity. Here it is half. So it is that substrate concentration where the velocity of the reaction reaches half its maximum value, and it's called as Michaelis-Menten constant or Km. So I hope I'm clear. So moving forward, how do we write this Michaelis-Menten constant? We write it in this way. Km, Michaelis-Menten constant, is equal to K2, where the enzyme plus substrate concentration changes into product, that reaction constant K2 plus K minus 1. Fine, I have made these parameters already clear, you must be knowing these things, and divided by K1. So this is K, the value of K1, Km, the substrate concentration at half its maximum velocity, is written as K2 plus K1, K minus 1 divided by K1. So fine, I hope I am clear with the Michaelis-Menten constant. So moving forward, what's there? Let me tell you Michaelis-Menten equation. We come to Michaelis-Menten equation. Now we know V is equal to, the velocity of a reaction is equal to V max multiplied by concentration of the substrate divided by Km plus the concentration of the substrate used in the reaction. So you already know Vmax is the maximum velocity after which the rate of the reaction starts leveling off, and S is the concentration of the substrate used in the reaction, and Km is the Michaelis-Menten constant, and you know how to derive this constant. If you have numericals in your examinations, you know how to derive this, and plus S again is the substrate concentration. So let me tell you, from this Michaelis-Menten equation, we can just conclude two things. We can conclude two things. When the substrate concentration was kept constant and enzyme concentration was increased, the rate of the reaction increased. First, what we do if we keep the concentration of the substrate constant, we don't add much of the substrate, we keep it constant throughout the reaction, and the concentration of the enzyme was increased. Concentration of the enzyme was increased. The rate of the reaction also increased. The rate of the reaction also increased. Now, second assumption which we can make from this equation is, when enzyme concentration was constant, if we do vice versa of this, यहाँ पे हमने enzyme की concentration जो है वो constant रखी, but we increase the concentration of the substrate. Fine, what happened? The rate of the reaction reached to the maximum. जैसे मैंने आपको अभी हाइपरबोलिक ग्राफ में दिखाया, रेट ऑफ द रिएक्शन जो है वो मैक्सिमम हो गई, एंड देन स्टार्टेड लेवलिंग ऑफ, उसके बाद वो लेवल ऑफ हो गई. why it started leveling off? When the concentration of the substrate was increased and enzyme concentration was kept constant, because all the enzyme present in the reaction was utilized, because all the active sites of the enzymes were occupied by the substrate molecules. Now if substrate is added, no enzymes or no active sites are present there to bind with the substrate molecules. So it starts leveling off. So this is the Michaelis-Menten equation and Michaelis-Menten constant I have told you. So these we will use in studying the enzyme inhibition, and we will be studying the enzyme inhibition tomorrow inshallah. And if there are queries related to this, please let me know. Thank you so much. Stay blessed and stay safe.